This will be the first video on our lesson 6.6. It's on the Pythagorean theorem. Before we even get into the Pythagorean theorem, we're going to talk about some skills that you're going to need to use in this section a lot. So the skill that we're going to talk about is using perfect squares. A number is a perfect square if you can take a different number and square it and get that number. So the perfect squares are these bluish numbers. I'll put them in a box right here. These are the perfect squares. 1 is a perfect square because 1 squared is 1. 4 is a perfect square because 2 squared is 4. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. That's why these are perfect squares. This perfect square list is found in the Files section under channel 6.6. So you can print this out and you can make a box around these numbers as well. Okay, so the first, I would say 10 perfect squares, you should probably be very familiar with. And knowing these really helps. If you don't know them so well, it's really important to kind of have this beside you. That way you can reference it. So all of these numbers are perfect squares as well because they come from a counting number squared. These are perfect squares also. Now, there's obviously infinitely many perfect squares in the world, but this is where the list ends at 25. Okay, now this is where the list comes in handy. If you want to know what 13 squared is, obviously you could look here and see that it's 169. Squaring a number is the same thing as multiplying it with itself. When you unsquare a number, here's what that means. You take the square root of it. So this operation of the square root is the opposite of the operation of squaring. So if you want to know what times itself gives you a number, let's say 361. What times itself gives you 361? This is how you write that. Square root of 361. What times itself gives you 361? 19. 19 squared equals 361. So the square root of 361 is 19. So when you take the square root, that's what this symbol is, remember. Take the square root of any of these perfect squares. You get a whole number. Okay, so for example, we'll do another one. What is the square root of 121? What times itself gives you 121? 11. You know that's the answer because 11 squared, 11 times 11, gives you 121. Okay, now you should have a calculator. If you don't, there's apps that you can download onto your phone to make your phone look like a calculator. We did that in class. If you're not sure of where to get one of these calculator apps, send me a message or something, I'll let you know. But you can type the square root of a number into your phone or calculator and it'll tell you what the answer is. Now, again, when you take the square root of a perfect square, you get a whole number. What happens if it's not a whole number? For example, what if you're doing the square root of, I'm just making this up now, 350? What times itself gives you 350? Well, look at your list. 350 is not on your list, but it would live right here. So your answer is going to be in between 18 and 19 because you know 18 squared is 324. You know that 19 squared is 361. So the square root of 350 is going to be 18 point something. And I can go even a little bit further. 350 is definitely closer to 361 than it is to 324. So I know the answer is going to be bigger than 18.5. So I might take a guess and I might say 18.8. I'm just guessing. But you could type it into your calculator, and that's what I'm going to do right now. And you can't see that I have my calculator here, but I'm typing in square root of 350, and it's going to tell me it's actually 18.708, so on and so forth. So I was pretty close with my guess. So it's actually 18.71. Right, but this is how you would use this list to help you.